Hi students, my name is Jayasri. I am working as Assistant Professor in Department of CSE AIML, working in MLR IT, and today's my topic is Introduction to Cognitive Computing. Before going to cognitive computing, let us see what is cognition, and before that, today's topics which I am going to cover in this session is what is cognitive computing, how cognitive computing works, and what are the fields of AI which produces number of cognitive technologies, and what are the applications where cognitive computing is used in the real world with use case, and what are the features in it along with digital transformation. Now, what are the technologies used? Cognitive technologies, like talking about the field of artificial intelligence, which has produced a number of cognitive technologies like computer vision, machine learning, NLP, optimization. Let's see in detail. Computer vision tells that you have a very specific information about anything, like you're talking about a data, okay? You're talking about a database, and in this you are applying a computer vision. Now this computer vision will have a very keen idea about what are the information stored in the database, what or how many registers are there, how many slots are allocated, what are the file names, what kind of data is stored in each individual file, what is the register, how many registers are there, and so on. So your computer vision will have information about each individual. This is just for an example about computer vision. And talking about machine learning. Now, machine learning is something that you have a machine and we are training it. Okay, we have a machine. We can either be a robo or a system. Okay, I am applying a machine learning onto a system or a robo. Now, according to the human instruction, my machine will be trained in such a way that it is working 200% efficiently. Accuracy is different. Accuracy is depending on the input data, depending on the application, depending on the technology we use, it will give the accuracy. Okay, it can be 94% accuracy, 95%, depending on what application we use. But talking about machine learning is something that we are making a machine learn about everything. As we have bulk amount of data, machine can be trained in all manner, all sorts. Next, NLP, natural language processing. Natural language processing is something that we speak. Natural language processing, NLP, is the language understanding. Okay, language understanding. That is, you are giving a speech, like you give a prompt to, we give prompt to ChatGPT, and we ask for result. So this kind of applications, this kind of features are seen in NLP, right? Again, we have speech recognition here, and rules based on systems, robotics, planning and schedule tells, sometimes we see in this busy world we have multiple issues to identify, like we have multiple works to be done on time. So what happens, we will not, as humans, we don't remember everything, wherein this comes into existence, like Siri, Alexa, okay Google. With the help of these assistants, we are able to do all the jobs on time, right? We are able to complete we are able to complete the promised job, promised work on time. We are able to attend workshops, book cabs, all the jobs, all the human related jobs are assistants like artificial intelligence, Google assistants. These applications are able to help us in planning and scheduling our jobs, right? And talking about robotics, like uh, in very many applications, many projects, like robotics play a major role. We apply a single application onto it to perform a major change. So robotics also play a very major role. Right. Now, cognitive computing basically are used in what applications, like banking and finance, education, healthcare, logistics, retail business, cyber security, and so on, right? So, where you don't find cognitive computing, you have nothing. Like, we don't find cognitive computing in everywhere. We use artificial intelligence, and the same way we use cognitive computing in all the applications to make the human work or human job easy. Yes. How is it used in the real world? What are the use cases used in the real world? One use case which I would like to discuss here is the first IBM Watson has been utilized in the healthcare industry to analyze medical records, and find insights to improve diagnosis and treatment plans. Now, it is very difficult for a single person or a patient to identify what's the problem by a normal report or paper. So here what happens is, using cognitive computing, IBM Watson first got the application, like which can be used in the improvising the diagnosis and treatment plans. What are the virtual assistants? I just told you, virtual assistants like Alexa, Siri, Google assistants use cognitive computing to understand natural speech, search vast knowledge bases, and respond appropriately in conversational manner. Okay. Now here virtual assistants like Alexa, Siri, Google assistants, these use cognitive computing to understand natural speech, search vast knowledge bases, and respond appropriately in conversational manner. And what are the next use case? Financial institutions. Financial institutions use cognitive computing system to monitor economic conditions, analyze financial transactions, and discover patterns. What kind of patterns can be discovered? Fraud and risk, which improves the compliance and protects against the threats. Okay. Now, using cognitive computing, when we are talking about the financial institutions, here it will give a threat prior, so that we are not into losses, we are not into high risks. Talking about retailers, who are our retailers? Like Amazon, Netflix. Now, these also apply cognitive computing to understand. What do they understand? The history and interest according to the customer. Now, the customer will keep on browsing or finding for some product for purchase or any requirement he has. He will be finding out or searching for a product. Now, according to the customer interest, your cognitive computing will have a track or history of that particular customer, and it will give you the recommendations likewise. So, the product recommendations are targeted promotions which can be presented. Right? Now, what are the benefits here while we are using or talking about cognitive computing? There are several benefits like improved decision making. Improved decision making by analyzing vast amount of data. Now, say I don't have any information. Say I am doing a research on some cancer or something, cancer or Alzheimer's. Okay. Now, I don't have the information of patients who are suffering with Alzheimer's. So, without having the raw data, without having the information, how can I do my research? There is no point, right? So, the information is very much important to perform any sort of action on it. So, by analyzing vast amount of data, my cognitive computing can provide insights. If it is having the information, it is having the data, it can provide some insights that it helps in making informed decisions, stating that this will be the output. If you are okay with it, it will give you the relevant output according to the requirement. Next, what is the next benefit? Increased efficiency. Increased efficiency, when you are talking about cognitive computing system, it will automate complex tasks, which leads to increased efficiency and productivity. Right? The next benefit is personalized experience. This provides the experience to users by understanding their preference, by understanding the preference and behavior. So, the first benefit tells that we are analyzing vast amount of data, and it provides the insights to help decision making. Next, the increased efficiency and productivity. The next benefit is personalized experience. Personalized experience for understanding their preferences and acting accordingly, right? Or acting according to the behavior. Another application, when you are using cognitive computing in digital transformation, we have different dimensions which we need to look into, like perception, reasoning, relating, learning. Okay. Now, talking about perception, this is basically used that which interprets the sensor input beyond the traditional data. Perception is something that we understand it by interpreting sensory input beyond the traditional data. What is traditional data? Traditional data is something that you have everything manually. Okay. The other advanced thing is you have everything automated or practical. You do any projects practically is the advanced level. You do projects manually or you do teaching manually is traditional method. Okay. Now, what is the other dimension is reasoning. This reasoning, it deepens our analysis and inspires creativity. It deepens our analysis. Now, say if I have to do some research on some cancer or any other disease, I will have some data wherein I need to analyze whether that particular disease can be cured with few medicines or drugs or something. So, for analyzing it, I need to inspire creativity. Like I need to do trial and error method. If a person is related to pharma or a medical related person, he has to check out with multiple combinations of drugs. So that is the reasoning for doing a trial and error method for finding out a solution for the problem, right? And the other dimension is relating. How do you relate? How do you understand? Personalize the interaction with each of us. The other dimension is relating. How do you understand? How is it related? Say the information which I am trying to analyze, I have to relate it with some other related content. Okay, so I need to understand how to communicate different areas. Along with that, personalize its interaction with each of us. Like, say I have A disease and B disease. Now there is some interlink between A and B. I don't have the information of how is it connected. So I need to find out the information key, how is it linked, and what is the disease or what is the symptom which is commonly seen in patient A and patient B. That is the finding out relation. That's one of the dimension. The other dimension is learning. Learn from every interaction, scaling our ability to build experience. We are learning all this. To scale up our experience, to understand, to improve the ability of understanding and scale up our experience in analyzing what is the solution for the problem given and giving a better solution for the next time, right? So let's see again in brief, like how is a fuel digital transformation being used. It first understands the language, generates and evaluates hypothesis. Now there is some raw data. For example, there's some raw data here, or there is some information about a patient or anything. Okay, there's some data, there's some content where gist of thing is around it. Okay, what is the concept here? That the node or the node A, it first understands what is revolving around it. Okay, it will first understand the language, irrespective of what language it is. It will convert it into its own language and understand what is the web trying to give information to it, right? And it generates and evaluates the hypothesis, like whether it is compatible to it, whether it is out of the range, or is there any other information that it has not related to, or no, it will check whether there is some compatibility or there's a hypothesis generated or no. And it adapts and learns. Now once it checks whether the hypothesis is generated, it will adapt and learn what is there in it. Okay, once it learns, it will get accustomed to the data, or it accustoms to the information which is revolving around it, and it tries to react whenever it comes into its contact. This is about fuel digital transformation. Now, in case if say, let me take one more example here. If there's a person who needs petrol at around 3:30 in the morning, okay, 3:30 a.m. and this fellow who needs petrol will request for 2 liters of petrol through an app. Okay, he will order it in an app, giving the location, stating that he is somewhere 2 kilometers radius. Your system checks whether this person who is requesting, where is the nearest point, where is the nearest location near to that person, and it will check. It will try to deliver within probably around 40-45 minutes. Okay, this is fuel digital transformation. A person who needs petrol at around 3:30 in the morning, where he's stuck on the road without petrol in his bike and he needs to reach his location. So instantly what does he do? He will open the app, he will order 2 liters of petrol, giving the location where he is stuck, and the system will, which is automated, will go and check the location of the person, and it will locate which is the nearest petrol pump near to that particular person, and gives a request to the people who are there, so that they can deliver on time, and the problem is secured, problem is sorted. Okay, this is one of the application for solving a problem related to fuel digital transformation. What are the features in cognitive system? Like adaptive, when we are talking about few features, one major feature is adaptive. Like we are adapting a system which learn as information changes, and a goal of requirements evolving, requirements which evolve. Okay, and the other is interactive. Here the systems which interact with each processes, devices, cloud services, as well as with people. The other is iterative. Iterative processes are generally used to solve problems which are ambiguous. So the other feature is stateful. This tells that it provides information that is suitable for specific application at that point of time. Next is contextual. This is basically used to understand, identify, extract contextual elements. These are few features of cognitive computing.